In this course, we treat flow as compressible when Mach number is greater than 0.3. In reality, density changes during many fluid processes. Variations in density of a fluid indicate differences in its refractive index. Refractive index is the ratio of the velocity of light in empty space to its velocity in a specific medium. Density and refractive index are related such that a material with greater density also has a greater refractive index. Light actually bends toward a fluid with higher refractive index or higher density. In transparent media such as air or water, we can use this to view phenomena which would otherwise be invisible. Two such methods to achieve this are known as schlieren and shadowgraph. There are many different setups that can be used to achieve schlieren imaging. All setups require the use of a knife edge. This serves to block light rays going through fluid of certain density while others are allowed to pass, forming both dark spots and light spots on the schlieren image. Another flow visualization method similar to schlieren is shadowgraph. Shadowgraph is simpler to achieve than schlieren. As the name suggests, shadow graphs produce a shadow of the phenomenon being imaged.